So here we are, learning how to divide complex numbers. Now, the basic idea here is that you have, a lot of time you have a fraction of complex number, like say 7 plus 4i, right, and divided by 2 minus 5i. The problem here is that I'm not happy with this expression. I'm not happy with the way how it is. I want to work it out and turn this whole expression here into something a plus bi. That's what my goal is. The goal here is I want it to be in the form. Okay, I want, right, this final answer. I want this final answer instead of giving a fraction that involves two i's like that. So I don't want this thing, right? I want to really divide it out to come up with some final one complex number like this. That's the point. Okay, so let's get into how to divide these two complex numbers here. So first of all, the one on the numerator here is the dividend, right? And the one at the denominator here is the divisor. Okay? So let's say how can we divide? Now we learn how to, at this point here, before you learn how to do dividing complex number, you must learn how to do how to find a complex conjugate. So if you haven't looked at the video of how to do complex conjugates, make sure you look at that complex conjugates video before you look into this, right? But then, to perform the division here, what I would need to do for the top, for now I would keep that the same way it is, right? But then at the bottom, the denominator is 2 minus 5i, right? And what I need to do to the denominator is I'm going to multiply the complex conjugates of the denominator. So the denominator itself is 2 minus 5i, right? So the complex conjugate of 2 minus 5i is a 2 plus 5i. Okay? So I'm going to multiply the complex conjugate of the denominator. I'm going to multiply that to the denominator. And also I'm going to multiply that same complex conjugates to the top because that's how we operate with fractions. So once you multiply a quantity to the denominator of a fraction, you need to multiply the exact same quantity to the numerator as well. So once again, the key step right here is multiply to the denominator its conjugates, its complex conjugates. Okay? So that's the key step. So now let's go ahead and you learn how to do multiplications, right? So on top here, I'm going to have 14, right, plus 35i plus 8i, right, plus 20i squared, right? And at the bottom you have 4. Now you always have the option to FOIL the bottom, but then notice I'm going to take a little short route right here. Remember the bottom here, the relationship between these two factors here is that they are the relationship between these two factors here is that they are nothing but just the difference of 2 squared, right, when you multiply it out. So what I have is I'm going to do 2 squared minus 5i all squared because that is identity number 3 can be used here, right? That is identity number 3. So for the denominator, I have 4 and minus 25i squared, okay? And remember, it's a little side note, I squared is always equal to negative 1. Keep that in mind. And so what I have on top here is a 14 plus 35i plus 8i, okay, minus 20. Am I right? And at the bottom here, I'm going to end up with, so on top that would also give me, so maybe I should produce one more step here. So I have 4 plus 25 at the bottom because I substitute the I squared with negative 1. Okay? And then at the top I have 14, right? Plus 35i, okay? Plus 8i minus 20. That's what happened on top. So at the bottom here, I'm going to just simply combine the like terms, right? So 14 minus 20 is a minus 6, okay? And then plus with a 43i and divided by 4 plus 25 is 29, okay? So that's what I have here so far. And so now at this point here, all I have to do is just break the fraction apart, right? Break the fraction apart. So I have minus 6 over 29 plus 43 over 29. I. So now at this point here, I'm happy. Why is that? Because my answer right now is in the form of an A plus BI. One complex number. Okay? So let's look into one of a formal example of dividing complex number here. So my first example for today, my example 1 for today. Okay, so how about we have, let's say we're trying to do, let's try to divide. So we got 6 plus 2i, right, divided by 4 minus 3i. Okay, so I want to divide this fractions, right? This the two complex number here. So the first thing to do, the key step here is I'm gonna at the bottom. I'm first for the denominator. I must look for its complex conjugate. So the complex conjugate of 4 minus 3i is 4 plus 3i. And what I would do to this complex conjugate, I'm going to multiply that to the denominator. And also, I'm going to multiply that complex conjugate to the numerator. So 4 plus 3i multiplied to the top. Okay? And then, now at the bottom, I'm going to turn out to have 4 squared minus, no, the difference of 2 squared once again, right? It's that formula number 3 again, identity number 3, so I got minus 9i squared, am I right? Okay, and then on top here, I have, after the FOIL, you can always have the option to FOIL, and you're going to have 24, right, plus 18i, okay, plus 8i, and plus with 6i squared. And that is going to give me, and remember, I squared equals negative 1. So in the bottom, I'm having 16 plus 25, plus 9, because I squared is negative 1. So with a negative 9 right there, it's going to give me a plus 9, right? And on top, I have a 24 plus 18i plus 8i plus, minus 6. Okay? So now, in my final, and then combining like terms, right? At the denominator, I have a 25 even. Okay, and then here on top, I have 24 minus 6 is an 18, right? And plus, now 18 plus 8 is a 26i, right? So breaking the fraction here apart, I'm going to have 18 over 25, right? Plus 26 over 25i. And that is how I can stop. That is the answer that I can stop and I can be happy with, because it's just simply it's one real component, right? Add with the imaginary components. And I do agree with you that when we get into division, a lot of times that we have to encounter with fraction like this. And make sure you reduce. In this case here, there's nothing to reduce, so I'm good right there. But make sure you reduce the fractions before we stop the work. Okay.